Okay, today we're going to do 9.5, which just deals with sine and cosine. So basically, we need to understand a little bit about how this works. So I'm going to look on page 264 first, and let's kind of go over what these stand for. So sine, A, is basically the opposite leg over the hypotenuse. Okay, and the cosine, A, is the adjacent leg over the hypotenuse. So what's important is that we have a right triangle, and what we need to understand is depending on the angle in which they give us is going to depend on what is the opposite leg and what is the adjacent leg. So the right angle will never fit in that category. You'll never have to worry about that. So let's just label these. So this is B, this is A. So this right here, of course, is my hypotenuse. If we're talking about angle A, then this is an opposite and this is an adjacent. Okay. So let's get into a couple things. First off, let's focus on trying to figure out what sine cosine would be. So if you look at exercises on 265, let's look at number 1 through 3. And this is basically going to help us kind of determine where are we beginning and kind of what we're doing with it. You will need a scientific calculator. Your cell phones do not always get this incorrectly. So please make sure you have your scientific calculator out. Be sure to understand how to do your sine cosine. Normally you push the sine or cosine button, type in the degree that it is talking about, and then times or dividing depending on the situation. So I will show you more of that on this video as we go through it. The first part's just setting up fractions. So let's do number 1. So here is number 1. It is a right triangle, and this is E, this is F, and this is G. So let's do sine first. So in this case, we have sine F. What does it equal? Well, in this case, we have to find the F angle, and it gives us 5, 12, and 13. So if we have sine F, we do the opposite leg, which is going to be 12, over the hypotenuse. So this is going to be approximately 0.9231. So now let's do the sine G. So sine G is going to be the adjacent. So if I go to G, adjacent leg would be 12. So I'm sorry, sine G would be the same thing. So it's going to be across the opposite, because sine does opposite. So it's going to be 5 over 13, which is going to give me 0.3846. Remember, sine is always opposite leg over hypotenuse. So depending on which angle depends on what's across. All right, so now let's do cosine. Now you're going to notice an anomaly that happens with these. So cosine, in this case it's cosine F, not A. So cosine F is going to be, here's my cosine F. I need to do the adjacent, which makes it 5, and it's still over the hypotenuse. So cosine F is the same as sine G. Okay, so that's something you're going to notice that happens. So that means cosine G should be the same as sine F. So let's look at this. So if this is here, we're going to have the adjacent leg, which is 12, over the hypotenuse. So in this case, we have 0.9231. So this is the same anomaly you're going to see with each of these. So let's work through them all so that you have a good rounding of your notes. So looking at number 2, we have, this is E, That's 72, 97, 65. There's my G, and there is my F. So I'm going to go ahead and write sine F, sine G, cosine F, and cosine G. That way they're already set up. We know they're going to all be fractions. I should have done approximate, so it should have been wiggly lines and not straight lines. All right, so the same thing here. Sine says start here and go opposite. So if I go opposite, that's going to be 65 over the hypotenuse, which is 97. The second one is going to be G. So G across is 72 over 97. Cosine says starting at F, the adjacent leg, which is 72, over the hypotenuse, which is 97. And then cosine G is the adjacent leg, which is 65, over the hypotenuse, which is 97. So for the first one, I should get 0.6701. Sine G is 0.7423. And then the same thing will happen here. So for sine F, I'm going to get 0.7423, and cosine G is going to be 0.6701. So as you can see, if I kind of separate them here, my sine and cosine are just flip-flopped. All right, because we're using the same numbers in these. All right, number 3. This is 90-degree angles. This is square root 2, and 2. So this is a 45, 45, 90. And we talked about this when we were doing our 9.2. So you're going to notice something that happens with all of them. So let's get them set up. We have sine F, sine G, cosine F, and cosine G. Okay, so if we start with sine F, the one across is going to be square root 2 over the hypotenuse, which is 2. So that is approximately 0.7071. Sine G is going to be the exact same thing because across here is going to be square root 2 over the hypotenuse 2. So you're going to get the same answer for both. So if I got the same answer for both here, guess what? Cosine is going to be the same. Because in cosine, we start with F, but the adjacent leg is still square root 2, and the hypotenuse is still 2. And with G, the adjacent is still square root 2 over 2. So for all the answers, it is 0.7071 for your answers on all those. So working through this are going to be the same thing. Okay, so now we're looking at number 4 through number 6. And this uses a little different theorem. So let me take and get a new sheet here. And what we're going to do here is we're going to take and do sine and cosines of complementary angles. They don't tell you that's what you're doing, but that's what's happening. So you're changing it from sine to cosine. So sine and cosine, like I said, have a very basic relationship. So if I'm starting out in sine, let's say sine A, and I want to go to cosine, I basically take 90 and subtract sine, or A, and it will give me cosine, and they call that B because after I change it, the two angles would be A and B. So if I was at cosine A and I want to go to sine, I do the same thing. It's 90 minus A, which is going to give me sine B. So let's take and put this back into a similar process. So 4 through 6 is doing this. So number 4 says we have sine 9 degrees. So that means I'm going to do sine 9 degrees equals cosine times 90 minus 9 will give me cosine 81 degrees. So basically you take the difference and that's going to be your cosine. So for number 5, we have sine 30 degrees. So cosine 90 minus 30 is going to give me cosine 60 degrees. So now I want you to try number 6. It is the same thing, so pause the video. And I want you to give me what the cosine is going to be for sine 77. So sine 77 degrees gives me cosine. You fill that in, and it's going to be cosine something degrees. So pause the video and go from there. Okay, let's check it. So I'm going to have 90 minus 77, which is 13 degrees. All right, so if you need to go back through and watch this part of the video again, I would stop here and go back and revisit the first half of this video. Let's look at cosine. So this is all sine. Let's look at cosine. So 7, 8, 9 is cosine. So cosine 15 degrees equals sine times 90 minus 15, which will give me sine 75 degrees. Number 8, same thing. Cosine 83 degrees equals, this is going to be sine 90 minus 83, which is going to give me sine 7 degrees. So now I'll do number 9, and I will give that to you. This is cosine 45 degrees. We're going to change it into sine. So pause the video if you need to, and finish this up. Okay. So hopefully you paused. We're going to subtract 45 from 90, and I'm going to get 45, sine 45 degrees. All right, so that's the end of the complementaries. Now we're going to get into finding the value of each variable using sine and cosine. So the key thing is you are finding sine and cosine. So you're going to use 2 different tactics to get these answers. So that's what 10 through 13 is going to be doing. So let's scoot this up so we have plenty of room. So for number 10, I have this lovely right triangle. And it's going to be x, y, 9, and this degree here is 16. I like to start out with sine first unless I cannot. So this one, all these you can start with sine first. So I have sine 16 degrees. And we know that's going to be that because you always put the degree in behind sine or cosine. Sine says it's going to be opposite over the hypotenuse. And the nice thing is that we actually have a hypotenuse. So this is going to work. I don't have to do any extra work here. So 16 equals, the opposite of this is going to be x over hypotenuse, which in the hypotenuse in this stage, I apologize, should be 9. So now what we do is we literally clear the fraction by multiplying 9 up. So it's going to be 9 times sine parentheses 16 equals x. So put this in your calculator, and what I would do is this, hit sine. So let me show you on the calculator here. Hopefully there's not too much of a glare. So we have sine, there we go, 16 times 9. And we do that, we get 2.48, which is 2.5. So 2.5 is what I get for my x. For my y, so cosine is what we're going to do here to get the y. Cosine is 16 equals adjacent over hypotenuse. Now keep in mind that you could do either one of them first. It does not matter, because when you're doing this and calling it cosine, it just means you're looking for the y value or the other leg. Okay, so you could have gone for the y first as long as you call it cosine first. So we have cosine 16 equals y over 9. So you're going to do the same thing here. So what I'm going to do is let me clear that. So instead of sine, you're going to have cosine. So we have cosine 16 times 9. And that is going to give me y is going to equal, and let me write this over here so you have this. You're going to have 8.7. And remember, you have to round it to the nearest tenth on your assignment, so keep that in mind when you're working this. Okay, so that's number 10. So let's look at number 11. So for number 11, we have another beautiful right triangle. This time we're missing both legs again. So this one has both legs missing. So I'm going to leave this one up to you guys. I'm going to set it up just in case you don't have your packet with you. But you're going to treat sine and cosine the same. So you're still going to do sine and set it up the same. And you're still going to do cosine and set it up the same. So sine 72, I made that one a wrong number. 72 equals, in this case, when you do that, your opposite is going to be n over 50. And then your cosine is still going to be 72, but this time it's going to get you the adjacent, which is m over 50. So you can work those two out and finish them. So pause it, and then we will come back and finish that. Okay, so I hope you've paused it. This is what you should get for number 11. So if you didn't get that, then I need you to go back and re-look at the content in which you've done. All right, so now we're going to do 12 and 13. Now I'm going to do 12 and then have you do 13 on your own because it's going to be the same concept again. Just remember that it's the same thing over and over and over again. So the first thing we're going to do here is sine and cosine. So let's do number 12. We have this lovely right triangle again. This time is C, this is D. This side is 47 degrees, and this is 10. So we're going to start out with cosine, and the reason why is that I have this here. So in order to get the hypotenuse, I am actually going to have to do cosine first, because cosine says adjacent over, which this is my adjacent, over my hypotenuse. And we couldn't do this over hypotenuse because I would have two variables that we didn't know, and that would make it more complicated. So we're going to start out with cosine 47 equals, now like I said, adjacent, which is to the right of whatever the angle is, that is going to give me 10 over our hypotenuse. Now this time with the hypotenuse, you're going to notice something. You're going to notice that we are going to have to multiply the d up and then divide the cosine 47 down below. So it's going to require a rewrite. So really this is going to be d equals 10 over cosine 47. So instead of multiplying the two of them, we're going to divide them. So when we put this in the calculator, and let me put this up here for you without the glare, we're going to have 10 divided by, now I put parentheses after it to keep it from getting lost, cosine 47, and then we hit equal. So this should give you 14.7. So D equals 14.7. Now, to do the sine, we needed this number for our hypotenuse. So remember, this is now the hypotenuse. So that was the D we were missing. So to get the C, we're going to use the other way. So this is going to be 47 degrees for sine. And this time we're going to talk about the opposite. So the opposite is what we're missing now over the hypotenuse, which is 14.7. So you could not do sine first without doing cosine because we didn't have the opposite angle. We had the adjacent leg, I should say, not the angle, but the opposite leg versus the adjacent leg. So this is just going to come up by multiplication. So this is just going to be sine times 47 degrees times 14.7. So let's put this in the calculator. So we have 14.7 times sine 47, and you get 10 point. Now they say 10.7 on your assignment, but it's really 10.8 because of how it rounded. So those are your two answers for C. Now, if they should count it wrong on your homework, then see if it didn't round it, because sometimes the rounding is a little iffy on the calculators versus their long scientific way that they do it. Okay, so number 13 is the same way, but I still would like to go through 13 and 14. So let's clear our sheet so that we have room. So for number 13, it's going to be the same concept. We're going to have 28 as one of our legs. We have A, we have 65, and we have B. So this time, they give us one that cannot be adjacent. As you can see, this is my hypotenuse. This would be my adjacent leg, and it is a variable. So we have to do sine first because it's directly across. So if we're going to start off with sine, 65 equals the opposite, which is 28, over the hypotenuse, which is B. So since we have the denominator as a variable, remember that means we're going to flip the sine 65 to the denominator and the B up to the side. So let's rewrite this before we put it into our calculator. Now, when we put this in our calculator, we are going to end up with 28 divided by, and remember parenthesis, sine 65, and you get 30.9 equals my D, or B, sorry, my B. Now, we're going to use cosine. So this is my hypotenuse. Remember, this is a hypotenuse. So when we do cosine, it is going to be still 65, but this time you're using the adjacent leg. So the adjacent we know we don't have. So we're going to put the A above here with the hypotenuse 30.9 up above. Now you're going to take and you're going to multiply that up. So we have our calculator here. Let's clear it. So we're going to have cosine 65 times 30.9, and that's going to give me my A. So cosine 65 times 30.9, and we get 13.1, because don't forget to round 0 up to 1 because you have a 5 in the hundredths place. Okay, so that is it for 10 through 13. The last part is making you set up the image. So for number 14, basically it talks about a kite, and it says that they are surveying a brush fire damage, and it's an enclosed off area. So this is kind of like the image. So this is the camera. This right here is the center point, center. And then this right here is your person flying it. And it says for part A, a person is standing 100 feet away from the center point. So this is going to be my 100 feet, or one of my legs. It says that the angle of the depression from the camera to the person flying is 25 degrees. In other words, the angle here is 25 degrees. So we are missing this here and this here. So to get the amount of string, it says, how long is the string? Well, we cannot use the opposite. The opposite's not going to work. So that means that sine is not going to work. Cosine will work because this is an adjacent. So we know we're going to use cosine 25 equals, this is going to be 100 over D. So once again, If you have a denominator that is a variable that your cosine or sine are equaling, you're going to switch them out. So it becomes d equals 100 over cosine 25. So let's put that in and see what we get. Now remember, we're looking for feet. So when we get done, we're going to round it to the nearest tenth. So 100 divided by cosine 25. Don't forget to put that second parenthesis on there. That's going to be 110.3 feet. That's how long the string is. Now let's do, this is part A, remember. So let's do part B. Part B says if the string is 200 feet and we're still at a 25-degree angle, then what is the distance across from the person to the center? Okay, and there's your camera again. So I'm looking for down here. So let's call that A and that C. So what's happening here is you can't do the opposite again. That's not going to work. So we can do the adjacent. So we're looking for the adjacent. So what I have here is we have the total feet and we're looking for the adjacent. So we're looking for this guy right here. So I'm going to use cosine again because we want the adjacent angle. So it's cosine 25 equals C over 200 because we already have the hypotenuse. So that saves us some time. So now you just multiply it up. So this is cosine 25 times 200. So this is what C is going to be. So if I put in my calculator cosine 25 times 200, you're going to get 181.3 feet. So that is how far away I am from the person to the center. That is 181 feet, 0.3 from what they have. Okay, so this is the end of cosine and sine for 9.5.